Okay, can you hear me? Yes, okay. Give me a minute to take the slides. Okay, are you able to hear me and to see the slides on your... Okay, everyone see the slide. Okay. So, welcome to the first exercise lesson on the course Artificial Neural Networks and Deep Learning. I'm Francesco Lattari, and I'm a PhD student. And today we are going to no, the slides are not available at the moment. They will be available on the website of the course at the end of the lesson. Yeah, thank you for... I have to start to record. Okay. So today we are going to see how to translate in practice what you have seen during the theoretical lesson with the Professor Matteucci. Before we start, I want to know from you if you were able to install TensorFlow and to start successfully at least one Jupyter notebook. I received many emails about a problem with TensorFlow, the version of TensorFlow based on GPU for the Mac operating system. My my first suggestion is that for the practical lesson, for the exercise we will see together, there is no need for a GPU. They are very simple. They are very simple exercise that do not need any kind of acceleration. So we can use you can use the CPU. But if you want to have some kind of acceleration and you don't you are not able to install TensorFlow GPU on your operating system, you can use actually Google Colab, which is a platform that has been used.
Come il debito?
No, l'ho dovuto mettere.
So please, someone is talking. Can you please disable your microphone? Thank you. Okay. So if you want to, also for the today lecture, but also for the project, students from last year used successfully the Google Colab, which is a service provided by Google to run notebooks, Python notebooks, and to use a free GPU and CPU. Obviously, there are some limits. If I'm not wrong, you will be able to run your notebooks for about 12 hours. After that period, you will lose your experiments and the machine turn off. But actually, there are some tricks like using Google Drive to save your experiments. So after the 12 hours, you can restart your experiments from where you stopped it, and by loading the weights of your model directly from the from Google Drive. So have a look to Google Colab. Actually, I can show you. Okay, let me. Okay, this is Google Colab for the one I haven't has never seen it, and you can, for example, run a new notebook. So if you try to run a Jupyter notebook, you will see that there is no difference with Jupyter. Actually, it's the same. The graphic changed a little bit. So you have a play button for running the cells, and you can add code cells or markdown for adding, for example, text on your notebook. And but the cool thing is that you have already all the basic libraries for doing your projects and for starting play with TensorFlow already installed, so you have not to install additional libraries. If you need some libraries that are not provided by Colab, you can run command with the symbol. So you can, for example, use pip install to, I don't know, for example, for Pillow and so on, and you can install additional libraries that are not provided. Then you can go to runtime. Sorry, this is an Italian version of the column, but you can change the type of runtime, and you can select if you want to use a GPU or a TPU. So for the one that wants to use this kind of platform, you are welcome to use it. There are no problems, and actually, if you are not provided with a GPU on your local machine, um, you can use this kind of platform for your experiments. Okay, so I can go to the slides. So actually, when you have seen a lot of stuff in your theoretical lessons. You've seen uh, neural networks. You will see convolution neural networks and different kind of layers and different, such as batch normalization and so on. And you, for running your experiments and for training your model, you need to implement all these kind of theoretical objects. And what you need is also a system which allows to manage all the data you want to use for training your network. So you have to provide a system to preprocess your data and to provide the data to the training. And then you have you have to write your optimization algorithm. So you have to do the math by yourself, and hopefully you want to do it in an optimized way, so to be run on a, for example, on a GPU. So, and then you want also to have a system to visualize your training, your model, that is how your model is learning. And actually, you feel like okay, it's cool, but probably if you want to do it by yourself, you probably end up by going crazy on and asking yourself why your model isn't learning actually. So the tool we want to show you during this lecture, that is Keras, allows to have a very high level is an high level tool for having all this kind of implementation for free. So all we need is a library, and this library is themed to be easy as possible. So as we can see later in the exercise, we will have some basic elements that we can combine to implement our model and our data preprocessing pipeline and so on. Keras actually provides a very high level of abstraction, but it is based on different backends. For example, it is based on Tiano or on TensorFlow or CNTK and so on, and it has and it is a Python based library, which provides also the CUDA kernels for running into GPU. Okay, so we among all this backend, we will use we use Keras with the TensorFlow backend. because there are some kind of cool synergy between the two, and they are very optimized to work together. And in particular, we will use Keras from TensorFlow. So we will start, as you have seen, we install the TensorFlow library and we access the Keras modules by through TensorFlow. Okay, before starting with the with training our first neural network, I want to be sure that you remember at least the basic concept of what is an array, what is an NumPy array, and because I want to introduce the concept of tensor. As we will see, for the one who have confidence with NumPy, a tensor is a data structure used by Keras, but also by all the frameworks like TensorFlow or Tiano or PyTorch and so on. And it is something that is very, very similar to NumPy. Also, the way we can manage this kind of structure, this kind of object, is very similar to what we will do with the NumPy array. So let's start by seeing some examples, just to recall some concepts. Let me open a Jupyter notebook. From now on, you, if you want, you can follow and try it by yourself. Well, to run the notebook as I write the code. So let's start with a new notebook. Sorry, I have to change. Okay, can you see the notebook? So, for example, if I write something, are you able to see it clearly, or you want me to zoom in? Okay. So I will write 2 lines of code that I can pass in your chat, and you can copy paste this to the first cell. This code allows to print or the variables in a cell. Without this kind of code, if you want to print 2 variables in a single cell, only the last one will be printed. So this allows me to print all the variables I want. Okay, so just run the cell with the code I give you. Okay, let's start by the first thing we have to do is to import TensorFlow. So import TensorFlow as TF. I don't know if you are familiar with this kind of import, if you have ever seen Python during your career, but this way I importing the library and I renaming in a shorter way. So from now on, TF is pointing to the TensorFlow library, and then we import NumPy. So we needed to make some kind of comparison with TensorFlow. Okay. Then, for example, we can print your TensorFlow version. Is in my case is the 2.2, and also we can access the keras libraries from TensorFlow by using this notation, and we can check also the version of keras. Okay, so in this case, I have the 2.3, and this is something that tells me that he's using the TensorFlow backend, but it's not a surprise since we are calling keras from TensorFlow. So, okay, so let's start by first creating some kind of array. So the data structure from NumPy, just to recall. So one way to create a NumPy array is to, for example, passing a list, using a list. So for example, let's create a 3x3 matrix. I don't know, 9. Okay, and so we can obtain a two-dimensional array by calling the np numpy array method, and we have to pass our matrix that we write in form of a list of lists, and we can define, for example, the type. Okay. I think that you are all confident with this kind of writing, and I think that almost all of you have already seen the creation of an array in the initialization of an array in NumPy, and then so we can, for example, we can print, sorry, the array we just created, and we can also have some kind of information related to the array, such as the type. Is in this case is an integer 32 bit, and we can check, for example, the shape of our array, that is a 3x3, and also the number of dimension of our array, that is 2, because it's a bidimensional array. So, okay, this is some kind that we already have seen. So let's start to, now we want, but we want to work with tensors. So let's see how we can create a tensor. So this, using a similar formulation, I can create a 2D tensor by, for example, declaring a constant. So calling the constant method from the library and passing the list that is representing my matrix. And also in this case, I can define, for example, d type for my object, and then I can show how is which is the phase of my tensor. As you have noticed, the formulation is very similar, and so in a similar way to NumPy, we can create tensors and we can show tensors. And a tensor is a data structure which encapsulates a NumPy array. This is the data that is contained in the tensor, and we have a d type for the tensor, and we have also a shape. And as for NumPy, so I show you that I say to you that you can that is very similar to NumPy. So, for example, I can create a tensor like, I don't know, using the method zeros. So if I want to create a tensor of all zeros, I can use this method and I can pass the shape, the output, the shape that I want for my tensor. And in this case, also the d type of my tensor. And then I have a tensor of zeros. Or if I want, for example, a tensor of all ones, I can run stuff like this. But also if I want, for example, a tensor which replicates another data structure. So I can call zeros like, in a way very similar. As you see, I can there are very similar methods that I use with NumPy, but I'm just changing the library. And in this case, I can create, for example, a tensor which has the same shape and the same d type of my array. So a tensor is nothing but the data structure which is used by all the deep learning frameworks like Keras, but also as I already said, TensorFlow or PyTorch, and so on. And this is the data structure that is used on your, for example, on your GPU. So okay, I can do other stuff like, for example, range tensor. I don't know. I can create a tensor that goes from 0 um, to 10 with step 2. So I have this kind of tensor, or I also convert a tensor, or convert another structure to a tensor. So suppose that you have you want some kind of initialization that is not provided by TensorFlow. For example, you want to sample from some kind of uh, distribution. Suppose that you want to sample from a Rayleigh distribution, for example, that I don't know if it is provided by TensorFlow, but you can use convert to tensor, and you can pass your you can give to this function your NumPy array. So, for example, you can call you can sample from the Rayleigh distribution from NumPy random, and then you can give your size, and also in this case you can, for example, give your sorry, this is the way. So the d type, and you will end up with a TensorFlow initialized by sampling from a distribution that was from an array that is initialized with a random distribution. Okay, so sorry, I'm reading the chat. So I have not the chat visible, so I can check the chat at regular in regular times, and then I can answer to the questions. So okay, sorry. Important. So you have some kind of problem with import the library. So okay, yeah, if you are using Anaconda, you have to activate your environment using conda activate the name of your environment, and then you will able to you'll be able to import the library. So which is a tensor. Tensor is an numpy array plus the type and shape. Yes. So the tensor contains our data, and this is the structure that is used by Keras and other framework. How it is? It encapsulates an NumPy array that is the data of our contained in our tensor, and has the type and a shape, and can contain as many dimensions we want. So we can represent as a tensor different objects. For example, an RGB image can be represented as tensor, as for example, which has 3 dimensions. So for example, we can have I don't know, an image with a certain height, a certain width, and then we have 3 channels for the colors, and these can be implemented, for example, by converting I don't know, to tensor image object from the pillow library into some kind of the type and so on. Okay. So you will have also all different kinds of you will have different kinds of you have all the mathematical operations such the addition, subtraction, and so on. And you can play also. You can rearrange you can manage your tensor by uh, by changing its attributes. So, for example, if we have a tensor 2D, which is an integer to 32 bits, we can cast the tensor, for example, to have another D type. And so we can change the D type of our tensor. For example, we can change the shape. So suppose that we create a tensor, a range tensor from 0 to 9. Sorry. Okay. And we want to convert this kind of tensor into a bidimensional tensor. We can obtain it by, for example, call reshape on our tensor, and by giving the desired shape. Or if you want to, okay, as for NumPy, the TensorFlow accept also negative indices. So, for example, if I want to obtain the same dimensional tensor, I can use formulation like this. And the last dimension is inferred by TensorFlow. So based on the number of dimension and on the number of elements, the TensorFlow is able to infer the -1 dimension. So I can also obtain a flattened tensor by using also reshape with. So suppose we want to obtain again our one-dimensional tensor. We can use the reshape on the 2D tensor, and we can give the shape with minus 1, and then we obtain the flattened version of our tensor. Okay, then we can also expand dimension. So very similar to NumPy, if you want, for example, obtain a 3D tensor from the 2D one. So tensor 3D, we can use expand dimension and giving the 2D tensor, and we have to say to TensorFlow which is the axis we want to expand. So, for example, the last one. So for saying to TensorFlow that we want to expand the last one, we have to use the -1, and which is the result of this kind of expansion. We are adding a dimension on the axis we want to expand. So on the last axis, we add another dimension. The number of elements is not changed, but now the b-dimensional tensor is represented with a third dimension, which is simply containing the last value. Okay, so let me. Okay, we can. Okay, let's say how to, for example, to perform slicing to the tensor. So let's start with again an initialization. For example, let's recreate the three-dimensional, the b-dimensional matrix. So we have this kind of tensor, and for example, let's say that we want to get the element 3, so we can access the TensorFlow the tensor elements by in a similar way to Python and to NumPy arrays. So, for example, I can use parentheses to square parentheses to say, for example, that I want the element in row 0, column 2. So the column are indexed with starting from 0, so 0, 1, 2, as well as for the rows, so 0, 1, 2. So if I want the element row 0, column 2, column 3, I can obtain it, and the result is again a tensor which has no shape, that means that is a single element, and with a single value of 3. Also in this case, I can use negative indices. For example, I can obtain the same element by using the -1 index. Or, for example, if I hate myself, I can use negative indexes also for all dimensions. So this is these are all similar expression for the same thing. I can use also the formulation with double point to take full slices of my tensor. So suppose that I want this part of the matrix, so the the last four elements on the bottom right part of the matrix, so the elements 5, 6, 8, 9, I can do it by using, for example, this formulation. So starting from row 1 to row 3, 3 is excluded, so it will take row 1 and row 2, and column starting from the 1 to the starting from the column 1 that is the second to the third. And I will obtain another tensor, which is a slice of my original tensor. Okay, I can. Okay, last example. I can keep, for example, the first row by keeping the first row and using only the 2.2 double points to take only the first row. And so on. If for example, I want the first row reversed, I can use this formulation that you will certainly you have already seen if you use Python during at least once in your life. Okay. Okay, another formulation to get the slice from the tensor is to use, for example, the slice function. I can pass my tensor, and I can give the starting a list of starting indices. So, for example, here I can say start from row 1 and column 1, and keep all the elements containing indexes 1 plus 2 and column 1 plus 2. So this is another formulation, but you will it's more intuitive to use parentheses for indexing. I can also, for example, use I can use, for example, the TF where in a similar way to NumPy. So, for example, I can use TF where tensor 2D okay, modulus 2 is equal to 0, so I can obtain this kind of indices, and then I can use these indices in another function, which is the getter nd, which I can where I can pass the tensor and indices, and I can get, for example, all the elements at that indices. Okay. So, okay, let's check the chat. And different axes, different in TensorFlow. Okay, still problems with TensorFlow. I didn't get how the negative indexes work. Sorry, maybe I can repeat because maybe I go too fast on indexing, supposing that you are familiar with Python, but actually, okay, indexing is actually very simple. So you can use parentheses and separated with values inside, separated by comma. So what you do actually is to get the element, for example, at row 0 So the order of your elements within the parentheses is the order of your dimensions. So the first element is on the first dimension, that are rows. The second elements are on the second elements refer to the columns, and so on. So if suppose that we have an RGB image, and we have the three channels on the third dimension, and I want to only the red color, for example, on the first channel, I can access to the red color by using 0 on the third dimension, and so on. This is true for all the dimension we have. So when we use negative indices, actually we start counting from the last element of that dimension. So when I call the -1 here, I'm not starting counting from I'm not start counting from, sorry, this is the columns. So I'm not start counting from 0, from the left part of my matrix, but I starting from the right part, so from the last element, from the last column. So when I call the -1, I say takes the last column. And every time, so for example, if I use the -2, is -1, -2. So I start counting in the other direction. It's very similar to, for example, here we use the -3 to identify the -1, -2, and -3 row, and -1 column. So I keep always the element 3. Okay. So this is just to recall some concept from the array manipulation, and to introduce tensors, which are which is the structure used by all deep learning frameworks to run computation on multiple devices. And let's start to see. Okay, let me start with a new. No, actually, I want to show the slide again. Okay. Sorry for I have a look on the chat. Can you explain the last example with the indices? Okay, so last example, this one. Okay, this one, the where method of TensorFlow allows me to evaluate a condition on my tensor, and I evaluate this condition for all elements of my tensor, and whenever this condition is true, I get the indices for the elements that for which that condition is true. Once I have the indices, I can use the getter and d on my TensorFlow by giving my tensor and the indices I found to get the exact elements on that on the elements corresponding to the indices. Forward screen. Okay. But there are still problems with TensorFlow. I suggest to the one that are not able to install TensorFlow to use Colab for the today lecture, and probably you have problem because you are using Mac. Okay, I don't have Conda terminal. Should I do? Actually, I never had a Mac, so I don't know actually to resolve for Mac operating systems, but yeah, I think that the faster solution is that you will follow using Colab, and then we can see together after the lecture uh, how to solve for this situation. What is interactive shell? This kind. Okay, this is allow me for the one that as I said, this is allowed me to print all the variable in the cell. So suppose that I don't know, here I print tensor and array. Let's see that you have all the two objects printed on your screen. If I don't use this code at the beginning, only the last one is printed on the screen. So this is just a trick to allow for printing all my variables.
Professor, can you share the screen, please?
Sorry, yes. Okay, can you see now? Okay, as I already said, this is just a trick to have my variables printed on the screen, all the variables in the cells, because without that code, if I print, for example, if I want to print both the objects, only the last one will be printed on the screen. So this is just a trick to avoid that behavior. Okay, so let me take again slides. So basically, you will find this kind of information that I directly show you in the notebook. You will find them on the slides. Yeah, just a note on the TensorFlow version. If you are familiar with the TensorFlow 1 version, the TensorFlow 1 version was based on a graph execution. So when you for example, create the tensor and you perform operation on the tensor, you were actually creating nodes of a graph. And so, for example, here, if I, in the example here, if I create, example, tensor 1, tensor 2, and then I sum the two tensors, and I want to print, we expect to have the results of this kind of operation, but what we have is a node of a graph. So that is called, for example, const 0, 1, 0, and add 0. So we have not directly the results of our operation, but we have a graph that has to be evaluated. So we have with TensorFlow 1, we had to create a session and then to evaluate, to run, to evaluate a specific node in a specific session, and then we get the results. This was very useful to, for example, if you think that you want to have operation and you want to you have your model and you want to optimize your model for example, to go into embedded systems and so on. So working with graph allows to optimize your computation. With TensorFlow 2, the default computation is changing. We have eager execution. So we evaluate our tensors and operation as we run it. So in a very Pythonic way. So if, for example, as we have already seen in the notebook, if I create again, if I run the same code on TensorFlow 2, I have directly the results of my operation, so I can evaluate my tensors. And this is a more intuitive programming styles, and it's very easier to debug. I worked with TensorFlow 1 for a while, and it was very difficult in case of, for example, your neural network is not training for some reason, or you have some problems. So it's very difficult to evaluate where your network is. Where your network is not going well, and which is the reason for your faults. In this way, we can debug you have an easier debugging system. Okay, we have already seen. So we have seen how to reshape the tensor, but you have also, for example, all the mathematical operation. Okay. Yeah, we can split. Okay, I didn't show this, but you can check by yourself. But you have two methods for splitting and stacking tensors. It's very similar to NumPy. So I can split my tensor in different splits with different sizes by passing the tensor and number or size of the splits and on a specific axis. Or I can, given different tensors, I can concatenate the tensors on a specific axis, and then I can obtain the stacked tensor. But now I want to show you how to the core of this library, which is the creation and training of a neural network. So this figure represents the basic idea of Keras, but in general, of the basic idea behind all the deep learning, a deep learning framework. So starting from the left part, we have the data. Obviously, we need the data for learning and to train our network, and then all the data we have that we have in our storage have to prepare it in some way. So typically, a typical pipeline for deep learning, so for training our network, consists in prepare our data, where in data preparation I put all the, for example, splitting of our data in training, validation, and test set. I don't know if you have already talked with the professor about cross-validation and the division of the data in different sets for training and to validate, so to assess the performance of our learning of our model during training, and also the test set on which we have to evaluate our very final model. But also in data preparation, we can we put also all the processing we need to do to our data, and so, for example, data normalization or data augmentation and so on, but also the division in batches for example, for mini batch gradient descent and so on. Then once we have our data prepared and ready for training, we have this kind of object that is typically called a training loop. A training loop is made by typically it's when we is made by different operations, is alternating two steps basically that are forward and backward operations, in which in the forward one we evaluate our model based on some kind of data we have on the data we have in input, and then we optimize. So in this loop we actually learn the optimal parameters for the task we are solving, and based on some kind of optimization algorithm we choose during our training. And then here we have also some kind of visualization of our results. All this picture is actually the standard of a deep learning, of a training of our neural network. And this picture is a standard of all the deep learning framework, included Keras. So let's start from the data preparation side. As I already said, Keras is a very high level framework, and in this high level framework we have some objects that we can use for all the parts of our picture. For the data preparation, so the loading of our data from memories and all the preprocessing we need for training, we can use an object that is called dataset, and which is part of the TensorFlow module data. And actually the dataset implements an iterator on our data and allows to apply some kind of methods which performs in an easy way some kind of preprocessing on our data. For example, we can divide our data in batches. We can apply to our data map function, which are actually function that we apply to every element of our dataset. We can filter our dataset based on some kind of condition, and we can shuffle our data, so we can rearrange the order of our data. And so there are different ways to create datasets. So let's start with with a new Jupyter notebook. Okay, let me. Let me copy paste the import of the libraries, and okay. So let's start by create some example of dataset. Can you see the notebook? Okay. So, for example, we can have different kind of datasets, dataset objects. So suppose that we want a range dataset that is a dataset composed whose elements are the numbers in a specific range we define. So let's call TensorFlow.data.dataset, and we can create a range dataset by using the range method by giving the start, the end, and the step. Okay, so we have a range dataset object made by integer 64 bit, and we can, for example, iterate on this dataset, and we can print the element of our dataset. So as you can see, we are cycling on the elements of our data, of our dataset, by simply using a for loop and printing the elements of our data. This is a very simple, it's a very basic dataset. It's just for show you some methods of the object, of the dataset object. So we can call, as I already said, different methods on a dataset object. For example, I can divide the dataset in different batches. So I can, for example, call datasets. So let's recreate the dataset, and then I can call the batch function, in which I can, for example, define that I want. So let's have a variable that we use as an hyperparameter. So let's say that we want to divide our data in groups of 3. So we can use the method batch, give the batch size, and I can say drop reminder, for example, to false. I will now, sorry, I will now explain all the parts. So let's have a look to the dataset we just created. So it's a batch dataset, and again, and then if we cycle on the dataset, what we have, all the elements of our dataset are tensors, where each tensor is a group of 3 elements. So the batch is very useful if we want, for example, to train our neural network based on mini batches, and in this way we can create tensors with a group of elements we decide with an hyperparameter, which is the batch size. Drop reminder false if the number of elements is not divisible for the batch size. We can have the last elements with the last group with a number of elements which is lower, and with drop reminder equal to false, we can decide to take also this element. If we say, for example, to drop reminder, then the last the group with a lower number of elements is dropped. Okay, so I can, for example, apply also a map function. So I can copy paste for the creation of the dataset and the division in batches, and then I can, for example, apply call the method map function, and which wants a function as input, and which we can define as a Python function. So map function, which takes an input, for example, and return the square of the elements. And then I can give to the map function, to the map method, the map function I just created. And then if I cycle on my dataset, I just obtain the same division in groups, but for each element of my dataset, I apply the map function. As you can see, we can concatenate this kind of function. So we can, for example, apply another map function. We can, for example, filter our dataset and so on. So, for example, let's suppose that we want, instead of the map function, we want to filter our dataset, such as that we can have even numbers. So I can use the method filter, and I can pass a filter function. And then I can use, for example, I can define this filter function such that I have to write a condition. So given an input, which is the input, I return the input only if the modulus 2 of that element is equal to 0. So this sorry. Yes, because actually the filter function has to be compared before the batch function. So in this case, let's cycle on our dataset. Okay, and in this case, I have a dataset of elements, of even elements. Okay, and then for the last important method we have with the dataset is, for example, the shuffle. The shuffle function allows me to reorder randomly my dataset. So I have to decide a buffer, which is typically equal to the number of elements. And I have to say if I want to reshuffle at each iteration. And then I can, for example, divide it again in batches. Okay, sorry, I have to write the range dataset. Okay, so we have a different order of my batch. This is useful during training. This is a typical operation that we do during the preprocessing of our data after each epoch, or after each training epoch, to avoid that overfitting. So this is one of the methods that we use to avoid that the model in some way learns the order of our data. So shuffling is always a good choice. And okay, then we have okay, another important. Okay, so this is our just to recap the method we have to remember for when operating on our dataset are the division in batches, the map function, which is useful if we want to apply a specific function to the elements of our dataset, and the filter function if we want to filter our data. and the shuffle if you want to change the order of our data. Let's see another method to create a dataset, which is sorry, there is someone has the mic open. Can you mute yourself, please? Okay, so another way we can create a dataset is from tensor, using the method from tensor slices. From tensor slices allows to create a dataset from, for example, from arrays. So which we can give as a list of array for. So for example, if we give, I don't know, let's sampling an array from a random uniform distribution of sides 10 to 2. So in this case, I'm creating an array with 3 dimensions that in this case, we can read it as an array which has 10 bidimensional metrics. So the first dimension is typically typically represent the batch of my data. And then, for example, I can have another array of random integers of 10 random integers of size. Sorry, 10 random integers from 0 to 10 as the bound of my uniform distribution. Okay, this is my new dataset. That is a tensor slice dataset, and is composed by each element. As you can see, the first size dimension of my arrays is considered as the batch size. If we check the shape of the single elements of my dataset is a bidimensional matrix, the first, and the second is a single integer. And the types are, for example, here floating point and integers. So if we cycle now on the on our dataset, we have this kind of elements. So each element is a bidimensional matrix. Each element is a couple. Sorry, is a couple. Is a pair composed by a bidimensional matrix and a single value. So, for example, here we have this matrix and 6 as integer, and so on. And this is very useful. For example, let's imagine that we want to solve for a classification problem. We will have here, for example, the images, and here instead the class corresponding to the target class corresponding to that image. So if you want, for example, to discriminate between cats and dogs, we can, for example, use this method to and here we can pass all our images of cats and dogs, and here 0 or ones, an array of 0 and ones depending on the class of the image. And as output, so we have the image and the corresponding class. This is it's quite simple. We can zip also the dataset. So suppose we have two datasets. So as before, I create a NumPy array. So and another data set which, for example, I can write the single elements. So here I'm sampling 10 numbers from a uniform distribution, and here instead I give to the from tensor slices a list of numbers from 1 to 9. So both the first and the second dataset have 10 elements. I can create, for example, the zip dataset, which is composed by calling the zip function from dataset, giving the list of the two datasets we want to zip. At this point, if I cycle on the zip dataset, I will obtain again a couple of elements which are taken from the two separate datasets and have been coupled together. So here we have the first element of the first dataset coupled with the first element of the second dataset, the second element of the first dataset coupled with the second element of the second, and so on. And this is quite useful, for example, if you have different preprocessing pipelines for different objects. For example, if we want, I don't know, again, if we want to solve for a segmentation problem, in this case, we can have, for example, a different data set for the images and different data set for the mask for our target, and then we have to put together the two data sets. We can use the zip method. Okay, so let's start to, for example, to solve a classification problem. So let's start to go into the details of our into the core of our lecture, which is about training your first neural network. So for this kind of problem, we can we will use a data set which is already provided by Keras. So Keras has some data sets that are already ready to be used, and we can find here a list of data sets which are already available. And in particular, today we will use Fashion MNIST, which is composed by images of 28 by 28 images, grayscale images. And we want to classify these images as one of the 10 classes. For example, I don't know, we want to say if an image is a dress or a sandal, a shirt, and so on. Okay, so let's start before going on to explain how to build the model. Let's start to
tipo è una cosa più ad alto livello che astrai.
Let's start to import our data. So, for example, we can call tf Keras datasets Fashion MNIST. So typically under the datasets module, you will find the dataset by simply using the name of the dataset. So fashionamnist dot load data. Okay, if this is the first time you use this command, Keras will download the images in the notebook.
Sorry,
Yes?
we don't see what you're writing.
Sorry, I forgot. I always forget to change the. Okay, can you see it now?
Yes.
Okay, sorry. So I can call the fashionamnist dataset from the datasets module, and I can call the method load data. If this is the first time you use this command, it will take a while to download the dataset, and automatically the method will provide you with the data already divided into training and test sets. So we will have the couple images and classes, so X-train and Y-train, X-test, Y-test. So if we check the shape of our training set, we will have 60,000 images, and Y-train are for each of the 60,000 images, we have an integer representing the class of associated to our image from 0 to 9. Okay, so if we want to, for example, use also a validation set to check the performance of our network during training, we can further divide the training set into validation set. To simplify the things, I can do it manually. So, for example, but typically you have to check that for a fair evaluation of your results, you have to check if that your validation set is equally balanced with the number of classes with respect to the training set. So you have to be sure that your validation set is correctly balanced. And then, so in this case, I'll be keeping the last 10,000 images for validation, and I will keep the first 50,000 for training. Why valid? Sorry, here is white train. Okay. Now my validation set is composed by 10,000 images and my training by 50,000 images. Okay, now we can create our dataset, and in which we have to associate for each image its corresponding target. One way to do it is to use tensor from slices. So our train dataset is dataset from tensor slices, and we can pass the couple X-train, Y-train. Okay, then we can, for example, shuffle randomly our data. Using as buffer size the shape, keeping the first element of the shape of our data, I'm declaring the buffer size with I declaring the length of my buffer size as the number of my training images, because the first dimension is this number, 50,000. Then let's start to think which kind of preprocessing our data needs. For example, we can our images are in a range from 0 to 255. That is our grayscale value. For example, we can normalize our image. One way is to use a map function. So our map function, let's see later which are the inputs, but we have to the inputs are, let's say, which are the inputs now. So the inputs are the x and the y, because using fractal slices, as you remember, give elements as pairs of tensor, where the first is the image and the second is the target corresponding to the image. So when we apply a function, a map function, we will keep as input the couple, image, target. Now only the image has to be normalized, such as the image will fall in the 0, 1 into the 0, 1 range. So one way to do it is to, for example, cast the image, which is an integer in integer format, to a floating point, and then we can divide by 255. In this way, by dividing by the max value, we obtain our image normalized into the range 0, 1. And then the target remain the same. It's our normalizing function, and then we can apply our normalization to the elements of our dataset by calling the map function, by giving it to by giving to the map methods the normalized image function. At this point, we want to, for training purposes, Keras wants the target to be in 1/0. Who remembers which is the 1/0 encoding? Did you see the? Okay, exactly. So, okay, I can go a little bit slower. So just to recap, we have this. We have loaded the dataset. So the dataset is divided into training and test sets. The test will be used for testing our final model. To evaluate the performance of our model during training, we can keep as part of we can keep part of the data for validation. Here I keep the last 10,000 images for validation, the first 50,000 images for training. Then I started to create the dataset object. In particular, I used from tensor slices, and I passed to tensor slices the couple X train, Y train. X train, Y train, this allows me to obtain a dataset whose elements are couples of images and target. And then I started to apply some of the methods the dataset is allows me to perform. For example, I want to shuffle my data to avoid overfitting. I mean, why we are using normalization? normalization is not needed, but it is typically applied to avoid our input to take the values that are too big, because during training we can it could happen that the network will give higher weights to inputs corresponding to higher values. Is a typically procedure. Normalization is typically applied before giving our data to the model, and actually here it is not so necessary, but I want to show you just for exercise with the mapping function and to show how to normalize your data with a mapping function. So we can do in this way. So we can define a function which takes an element of our data, of our data set, but an element of our data set is composed by two objects, which are the image and the target. And then I return the input, which is the images, divided by 255, so that the output is the input is normalized between 0 and 1, and the target image. After that, I apply the map method by giving to the map method the normalizing function. Now, Keras, for solving a classification problem, wants the target to be expressed in one-hot encoding. Now, one-hot encoding is a formulation through which a number is expressed as a vector of 0 and 1s. In particular, for example, the class 1, suppose we have the class 1 of the 10 classes of the problem. So we have 10 classes. We have the one-hot encoding, for example, of the class 1 has a 1 corresponding to the index of that class, and 0 is a vector of the length of the number of classes, and a 1 corresponding to the index of the class of interest, and zeros everywhere. So if I want to represent, for example, the class 2, I have to put a 1 corresponding to the index of the class 2. If I want represent one-hot encoding the class 8, I have to put a 0 on the class 8 and 0 on the other indexes, and so on. Okay. So how can I convert the target to one-hot encoding? I can use another mapping function. So I can, for example, define a new function, which is the categorical one, and I can return the image as it is, because I don't want to apply any kind of function to the image, but I want to transform to one-hot the target. We can use a method from TensorFlow that, with not so fantasy, is called one-hot, and I can give the target, and I have to say to the function how many classes I have. Again, I can call the map function, giving to the map method the two categorical function. Okay, which other kind of transformation I can do with my dataset? I can divide my dataset, for example, into batches. So I can decide a batch size, for example, 32, but you can use also bigger batch sizes if they stay on your memory. And I can use, again, the batch method, giving the batch size. Okay, now I will use a method that we didn't see, but it is very important, which is the repeat. Okay, during training, as you probably already saw as you already seen in the theoretical lesson, an epoch, a training epoch is typically we refer as training epoch when we process all the data in our dataset. So when we see all the images in our data, then it is an epoch. If we want to perform a training for multiple epochs, we have to call the repeat method of the dataset. Otherwise, the training will stop after the epoch because the queue of our data is all consumed. So repeat is very important to allow for training for multiple epochs. Too categorical is not defined. Too categorical. Why is not defined?
Sorry, Prof.
Yes.
He failed to write to categorical. It's written to categorical.
Ah, sorry. Thank you. Okay, so we can copy paste this code for the validation set. So copy paste this cell and change the train with the validation set. So X train becomes X valid, some train becomes Y valid. In dataset becomes valid dataset. This way. Okay, and for example, we can decide different batch size for our validation set. If I can simply, for example, put a batch size of 1, and I can have a batch size different from training and validation. And the same, I can do it the same for the test set. But for now, let's forget about the test set. Okay, so let's see if all is correct, at least for the data preparation side. So, for example, we can iterate on our dataset. We can define the iterator on our dataset. So this formulation allows to call the, for example, the next method on my dataset. So I can get the image, which I call sample here, and the target by calling the next on my iterator. Then, since my sample is composed by 32 images, I want to show, for example, only the first. I can use indexing to get only the first image. Then, for example, I can, use I can multiply my tensor image with the scalar underscore mul for a scalar value. So I am denormalizing the images. So the images are in 0, 1, and I transform back the image into 0 to 155. And then I can, for example, call the pillow library. So from pill import image, which allows to manage image objects. And I can create an image from array, which wants an unsigned integer with 8 bits. And I have to convert the tensor into array. This is just for visualization purposes. So then I can resize my image. For example, this is a method of the library which allows to resize the input image to a shape that allows me to visualize correctly the image, at least because 28 by 28 is very small image. And then I can show the image. Yes, I have to. Okay. I don't understand why it is completely black.
Professor, you multiplied the data by 205 twice.
Yes, but I already. Yes, maybe. Okay, sorry. You're completely right. I mean, this is. Yes, we can simply multiply the probably the array, and we obtain. So see, if you run the cell, you are able to see all the image of our data set, and you can, for example, print also the corresponding target. So that is the one-hot vector, but why the one-hot vector is always zeros? Very strange, because okay, not categorical. I don't understand why, if I take the first tensor, it is always zeros. But if I show the target, it is correct. Maybe I have to. Strange, because the target is correct. So you have 32 images. For each image, you have the one-hot encoding. But if you print only the first, it will give only zeros. I don't understand why. Okay, but it seems to be correct. So, okay, so let's see Let me come back to the slides. So the one of the first objects you have seen in the theoretical lectures are fully connected layers that are, as you I mean, are composed by a specific number of neurons, and and they perform the weighted sum of our inputs, followed by an activation function. And I think that this is the first thing you have seen during the lesson with the professor. As I already said, Keras allows to build this kind of layers in a very high level manner. For example, for calling the fully connected layer, we can access to the module layers of Keras and create an object dense which have some kind of parameters. For example, the number of units and the activation we will use for that layer, and the initializer for our weights, and so on. For all these parameters, there are some modules which allows me to define the initializers or to define the activations. But the core, it's like to play with Legos. I mean, we have all these layers, and then we can group together these layers to build our model. And how we can build our model? We can do it in two ways. The first is to create a specific layer that is called input, which represents the input of our model, in which we have to define the shape that will have our input and the type. And then we can create every single layer, and we can concatenate the layer to by creating, for example, the first layer, and then passing to the first layer the first input, then the second layer, and giving as input the output of the first layer, and so on until the output. And then we have to create an object model defining which is the inputs and which are the outputs. In this case, which have to define x as the inputs and out as the output, and then we can use the model. Or we can use, for example, the sequential object that is a sequential that is treated as a list, and we can list all the layers which will be treated as a sequence of layers. So we have not to specifically say how the layers are concatenated to each other, but we can simply add the layer to the list, and then the model is evaluated sequentially. Then we can, before training, we have to compile our model. So we have to call the method compile by defining the optimization algorithm we choose, the loss, the error function we want to minimize, and some kind of other parameters such as the metrics we want to evaluate during validation. Also, in this case, we have different modules for defining both the optimization or the losses and the metrics. Then, once we have compiled the model, the model, we can start the training by calling the method fit, by giving to the fit method the input, our training dataset and our validation dataset, plus some other parameters such as the number of epochs we want to train, and so on. So let's say, I don't.
Sorry, Professor, we can't hear you anymore.
you hear me? Okay. Sorry, I have to restart because I have some problem with the mic. So let me show you. I will upload the notebook on the website of the course, but let me show you because we have no time to remaining time. Let me show you how to build and train the neural network with an already prepared notebook. So yeah, I will record. Don't worry, I will record also in the second lecture. For one who want to, I will go faster in the second lecture. So for the one we want to remain, can participate to the second lecture. But I will record the second lecture. So I will publish that recording. Okay. Okay, let me share screen. Okay, can you see the screen? I think yes. So let me rerun some cells, at least the one that we need.
Professor, we cannot hear you. Professor, we're not able to hear you. No?
Lo sa già, leggi i messaggi.
apply to everything because it actually doesn't require any prerequisite on the data.